Hi Year 12s, I'm going to show a different approach, so using linear combination to show that we have divisibility by a particular number. Okay, so we're going to start with A is 10q plus p plus q, and b is p plus 3q, and p and q are integers. First we have to show that 3a minus b is divisible by 29. So we're just going to start from 3a minus b. Okay, and then we have a definition for A and for B, so we put those in place. Okay, and then we do what seems obvious, which is expand out the brackets and simplify. So what have we got? 29p plus 0q. So we can see that is divisible by 29. Okay, and it doesn't matter what p and q are, that's still divisible by 29. Okay, so now it says hence, so we're going to use this answer or this result to prove that if 29 divides A, then it divides B, and if 29 divides B, then it divides A. So we'll start with 1/2. So if 29 divides A, okay, let's just look at this result we've got here. So we've got a 3A minus B. So I'm going to connect this to the 3A first of all. Then 29 divides 3a, okay, and since 29 we've just proved divides 3a minus b, it's got to be the case that 29 divides b. Okay, right, so let's go the other way around instead. So if 29 divides b, and here we just have a single b, so that's fine. We don't need to multiply it up. And since 29 divides, we showed that it divides 3a minus b. Okay, then that tells us that 29 divides the other term, 3a. Okay, so if b is a multiple of 29, and we have a sum of terms here, then the first term has also got to be a multiple of 29 for us to be able to take the factor of 29 out to show that 29 divides the whole thing. Okay, so now here we haven't just got a on its own, so we need to use Euclid's lemma. So the highest common factor of 29 and 3 is 1, so that means by Euclid's lemma, 29 divides a. Okay, right, so we've shown it one way and we've shown it the other way. 29, if 29 divides a, then 29 divides b, and if 29 divides b, then it also divides a. Okay, so then we're going to use this to devise an algorithm to show that this number is divisible by 29. Okay, so let's just have some more space. So what we do is we do f of the one with a power of 10 in it is equal to the other one. So we've got a function of a number in the form a is equal to a number in the form b. So f of 10a plus, p plus q is equal to p plus 3q. So we're now going to find f of 198,766. So that means we have to write it in this format. So we've got 19,876 times 10 plus 6 would equal our original number, but it's now in a format where p is equal to the 19,876 and q is equal to 6. So we can work it out. So we've got 19,876 plus 3 times 6. So let's just figure out what that is. So 19,894. Okay, that's still a massive number, a bit tricky, so we're going to use the function again to reduce it, because we know that if 29 goes into this number, then it goes into the number in this format from what we did in A and B. Okay, so we can take this one, write it in this format and get a smaller form and keep going until we get something that's easy to tell if 29 goes into. So f of this is going to be 1,989 times 10 plus 4, and that will give us 1,989 plus 3 times 4. 2001. Okay, so now we're doing f of 200 times 10 plus 1. That gives us 200 plus 3 times 1. So 203. And then if we continue, excuse me, so that'll be 20 times 10 plus 3, writing it in the format of A, is going to equal 20 plus 3, which is 23. And I think we've shown that it's not divisible by 29. Oops, so it's 3 times 3, not just 3. So that's 29, which is certainly divisible by 29. So 29 goes into 29, which if we follow back through, because it goes into this format, it also goes into that format and so on. So ultimately that means that 29 divides 198,766.